Welcome back, everybody. So, in the last session of this lecture for this week, we were talking about the data structures. So, now we will continue that section. Uh, so, let's start the second session of our lecture. So, this was the brief introduction about myself and the course. These were the things that we have already discussed and covered. These are the different types of data structures. Basically, I am giving you the fast recap of the course. So, we have done up to here in the previous session. Now, in the second session of the lectures for this week, we will start from here. Basically, why we need data structure. Basically, the goal is to organize the data, and what is the criteria? Basically, to efficiently store the data, to retrieve the data. Retrieve basically uh, go and collect the data. Retrieval means to visit and collect the data. And then manipulation changes in the data and design issue. Select and design appropriate data type. That is basically our design issue. So here we were reached basically data structure operations. What are the data structure operations that we can perform? Two of them we have, three of them we have discussed here: manipulation of data, retrieval of data, and storage of data. So here is the operation basically traversing, basically visiting the data and searching in the data, insertion in the data, deletion in the data. So these are the different operations that we can do with our data. So basically, there are some dictionary operations that is related to sorting the data or merging the data. So these are some of the data structure operations that we can play around with our data. So as in this session, our main focus would be related to discuss the program efficiency and time complexity. That was related to the previous session. Here in this session, our main focus would be to find the program efficiency. Why we need different data types, how it is affecting the efficiency of our program. So we will also discuss about the time complexities related to data structures. Okay, as we have already discussed about the algorithm. So basically, what is algorithm? As we know that data structure and algorithm both are interlinked with each other. We will discuss algorithms in detail in the next course. Uh, but I will talk about the algorithms time by time as data structure and algorithms are interdependent on each other. So basically, algorithm is the finite sequence of instructions. So it is basically a finite sequence of instructions. Then each instruction having a clear meaning. Basically, each instruction should have a clear meaning. There should be not ambiguity in the meaning of that. Then each instruction requiring finite amount of effort. So there should be everything should be clear as we mentioned in the previous property. Then next property is that each instruction requiring finite amount of effort. That effort should be finite. It should not be infinite. So uh, next is each instruction requiring finite time to complete. That it should be defined. time should be defined means that it should have finite time, not infinite time, or our program goes in infinite processing. So these are the properties of any algorithm. So then it comes the explanation of that properties that we have already discussed. The finite sequence of interaction and instructions, and input should not take the program in an infinite loop that we have discussed. So each instruction having a clear meaning means that it is very subjective. It is basically specific, subject specific. Basically, uh, what is clear to me may not be clear to you. It varies, depend on your point of thinking, or that's why I said it is very subjective. So some things that are clear to me, but they are not clear to you, or some things that are clear to you, but they are not clear to me. And every person can have a different point of thinking, so different way of thinking. So each instruction requiring finite amount of effort. So that is also very effective, very subjective. That effort should be finite. It should be finite. Machine can be any machine. That can be a supercomputer. That can be a simple P4, or that can be i8 or i7. So it should be effort should be finite. Each instruction requiring finite time to complete. So that is also very subjective. There should be some finite time for completion of any instruction given by the user. So it can be 1 minute, it can be an hour, it can be a year, it can be a lifetime, but it should be finite. That is also very subjective. Okay, let's move to the next. What is the definition of algorithm? So a finite set of statements that guarantees an optimal solution in a finite interval of time. This is basically our algorithm definition. So it is basically a finite set of statements that guarantees an optimal solution. Here, most important things are three things: finite set, the other is second is the guarantees, and the third is the optimal. The solution should be optimal, or in other words, the best infinite interval of time. So this is the requirement for any algorithm to be more the best algorithm. So these should be the three things that we need to focus while writing any algorithm. So again, uh, what is the criteria for the good algorithms? Run in less time, consume less memory. Out of which is most important? Either the time is important or the memory is important. What do you think? Think for a while. Answer is written on the slide, but as you know that time is the most important thing in our life or in everywhere. Uh, Memory, you can see that memory is increasing with the passage of time. We before if we talk about the USBs, that was only some MBs. Now we are having USBs of GBs, even TBs. So memory matters, but it does not matter so much. Main thing is the time. So but computational resources, time complexity is usually more important. As I was talking uh, uh, on the similar backgrounds. So time complexity, or the less time, run in less time, is the most important thing for any algorithm. So memory can be managed somehow with the passage of time. Okay, how we can measure the efficiency? Measuring the efficiency of the algorithm. So the efficiency of an algorithm is the measure of amount of resources consumed in solving a problem of size n. There is some arbitrary size n. So the basically the efficiency of algorithm is the measure of amount of resources consumed in solving a problem, the amount of resources that are consumed in solving the problem of size n. So the resource we are most interested in is time that we discussed in the previous slide. We can use the same techniques to analyze the consumption of other resources, such as memory space. So, as I have given you the example, that memory space can be managed somehow with the passage of time. Where, so, we can use the same techniques to analyze the consumption of other resources. So, we can analyze the consumption of other resources uh, based on the same techniques. It would seem that most obvious way to measure the efficiency of any algorithm is to run it and measure how much processor time is needed. So, how we are measuring the efficiency? We can choose the same criteria or condition for any program. So, from that, the most important thing would be the our time. So, if we are running the same program on the two different machines that have the same specifications. So the machine that is uh, good one that have the higher specifications would consume less time, and the other machine uh, that have the lower specification that would consume more time. So basically, the time is the most important thing. So other resources can be managed somehow. This is simply uh, the essence of this matrix that is basically measuring efficiency. Okay. Mm, next, we are already discussing these things in the previous slides. The factors that are affecting hardware, that is your computer system, operating system, compiler, size of input, nature of input, and algorithm. So which should be improved? Which thing should be improved to get better efficiency? Here is the explanation for that. Running time of an algorithm depends on two main things. One is the input size, the other is the nature of the input. What is the nature of the input? So generally time grows with the size of input. So if the input is very large, so it would take more time. So running time of an algorithm is usually measured as a function of input size. So generally, time grows with the size of input, as I already mentioned this thing. So the running time of an algorithm is usually measured as a function of input size. So they are interdependent. Running time is measured in terms of number of steps or primitive operations performed. So how we are measuring the running time? Running time is basically the number of steps that that program will need to complete any job. So it can be steps or primitive operations. So it is independent of machine or the operating systems. So your machine can be have good specification. Your machine can be of a good operating system. So main thing is the input size and the nature of the input. So these are the two main things for running time of any algorithm. So finding running time of an algorithm or analyzing an algorithm, so how we can find the running time of any algorithm. So the running time is measured by number of steps or primitive operations performed. So basically it is running time is measured by number of steps or the primitive. Primitive means basically basic operations performed. What it means by steps? Steps means elementary operations, or as I mentioned, basic operations. like minus, plus, multiply, less than, equal to, a of I, that is basically our array. That name is A with index I. So we will measure the number of steps taken in terms of size of input. So we will, our number of steps are depending on the size of input. Here comes the simple example for explaining this thing. Input. Basically, that is of integer type, an array that's name is A of n, array of n integers. The size of the array is n basically. So it is an array of n integer. So we need the output sum of all numbers in an array A. So what is the requirement? We need the sum of all numbers in an array A. So for this, we need method or the function. We have created the method or the function with the name sum. So it is taking the parameters integer type A uh, array with int n. So next is the we are initializing the variable s equal to 0. So here comes our loop. For loop, basically we are initializing it with I equal to 0 and I is less than n and I plus plus. This is basically the syntax for the loop. That is for loop. We are initializing it with 0 value and the condition for the loop, it would be true until when the value of I is less than n. So, and it would be the on I every iteration, it would be the increment of 1. So here we are on every iteration. What is our target or the required output? Basically, sum of all the numbers in an array A. So we have the array A. So we have to do the sum of all the numbers. So basically, we are storing it in the S equal to S. This is the previous value of S in the previous iteration, and here A of I is the name of the array, and every on every iteration the value of I is updated. So it would store the add it with the previous value of S and store it into the S, the new value. So when this loop is finished, it would return the value of S. How would you analyze this thing? This thing is explained here. That is a simple example that we are discussing in the previous slide. As you can see, that these are the instructions that are being executed once. Mm, we have initialized s is equal to 0. It would be executed one time. Then for initializing the value of I within the loop for, so it would also execute one time, and next return statement that would also execute one time during this complete program. So these three statements would be executed one time, and the other statement would execute how many times? N times, up to n iteration. On every iteration, it would check the condition and it would give the increment of 1, and it would update the value and add it and store it into the S. So 3, 4, 5, 6, and 7 operations, 5 operations, they are also executed once per each iteration of for loop. So there would be total n iterations. So hence the total would be 5n plus 3. it would be the total. Uh, and this is the formula for finding the complexity function of the algorithm. So this is finding the complexity of this uh, program or algorithm. So basically, f of n is equal to 5n plus 3. N is basically number of iterations. So these 5 is coming from here. If we count 1, 2, 3, 4, 5, they are executing all the n times. And this 3 is coming from here. 1, 2, 3. So this is the complexity function for this simple program. So let's see how this complexity function is behaving or working. So this is the complexity function for this simple program. Okay, before ending this part of the video session, I would explain this complexity function with some different values of n. Growth of basically growth of 5n plus 3. So if I want to find the running time for the different values of n, estimated running time for different values of n, if I take n is equal to 10, I put it here 10, it would be 5 into 10, 50 plus 3, 53. It would be taking 53 steps. If the value of n is 100, it would be taking 503 steps. Similarly for 1000, 5003, and similarly for 1 million, it would be 5 million steps. As n grows, the number of steps grows in the linear proportion to n for this function sum. For this function sum, so it is our complexity formula, complexity function is behaving in this way. So what dominates in the example that we are discussing now? So let's finish this before this video, or we should start this in the next video. I think we should discuss this remaining part in the next video uh, to make it more clear. Okay, see you in the next video. Thank you. Let me check how much is the duration for this video. Mhm. Okay, let me stop here.